Welcome back to this video series on the topic of fulfilling factorization. Chapter C, Perfect Squares. In this lesson, you'll learn how to factorize trinomial expressions containing the perfect square situation. A perfect square arises when a term is multiplied by itself. So if we have the term a plus b and it multiplies itself using the squared symbol, then what we have is the perfect square. This expands outward to become a squared plus 2ab plus b squared. But what we're looking at in this lesson is not how we can go from the factorized form to the non-factorized form, but rather how can we go from this expanded form over here into this factorized form. So what I'm going to show you is some small things that you can look out for to identify the perfect square situation. Let's have a look in example 1. Example 1. Factorize the following expression. We have x squared plus 4x plus 4. What I first want to do is I want to be able to identify whether this is a perfect square situation or not, and if it is, I'm then going to use the shorthand form to factorize this. Now, to be able to understand whether this is perfect or not, what I need to look at is this expansion form over here. In the expression on the right, you've got a plus b, but the expanded form, the second order term is always a square, and the constant is always a square number as well. So what I want to do is firstly I want to take the square root of this, and then rewrite it as the square of a square root. So doing the first one, it's just x in brackets and then squared, 4x, and then square root of 4 is 2. So I can rewrite it like this. So far it's looking like it could potentially be a perfect square. So a squared, x to the square, b squared, 2 to the square. Next, I turn my attention to this linear term here. What I need to do is I need to rewrite it such that it is twice the product of a and b. So if I start off and I firstly pull out the 2, what I have left behind is the 2x plus 2 squared. So instantly what you can see here is that we've got the x and the 2 and the 2. And because we're able to bring it down into this form over here, what we have is we have the perfect square situation. And because of that, we can simply go x plus 2 squared. So a and b, and this is our factorized form here. So the factorization itself is actually quite trivial. Where the expertise comes into is knowing whether it is a perfect square situation or not. And the way in which you can do that or assess whether it's perfect or not is you try and take the square root of the first and the last term, and then you check whether the middle term is the product of the square root of the first and the last multiplied by 2. So like this. When you get proficient, you can go from here straight to there, but for now, we're doing all the steps. Okay, next one, we have x squared plus 25 minus 10x. Now looking at this, the form is not what I'd like it to be in. Notice how it's got the x squared or the squared term, then the constant term, then the linear term. We need this to be in squared term, linear term, constant term. So I'm just going to quickly shuffle this. Now we need to check for the perfect square situation. So again, I'm going to try and square root the first and the last term. So x, square root of x squared is x. So it's x outside squared, minus 10x goes here, plus square root of 25 is 5, and 5 squared. Okay, so this is looking all right so far. Next, I want to split the linear term. So it will become plus 2, and then minus 5x plus 5x squared. And it's here where we hit a bit of a bump. We do have this x over here and x over here, and we do have the 5 and the 5, but where we have our problem is we have the negative there. What we need to do is we need to do a clever manipulation. Rather than just having the minus or the minus by its own, we need to box that minus 5 together. And we're allowed to do that because if we look at the square over here, we can change this 5 into a minus 5 squared, and that will still, minus 5 squared will still give us 25. So what we're dealing with is something that looks like x take 5 all squared. So this is our perfect square factorization there. So if you find that you're in a situation where there's a negative in the linear term, then it still could be a perfect square. It just means that your b over here might actually be a minus 5 or a minus number. So this is how we might identify perfect square situation. So in summary, in this lesson we had a look at how we could factorize perfect square situations. The way in which we do this is we slowly rearrange our trinomial expression into the form that would be a perfect square. And if it works out, then it means we've got the perfect square situation and we can just go from here straight down to there. When you become more proficient at this, you'll be able to go instantly from, say, this line over here straight down to there, or this line over here straight down to here. But for now, we need to show the full working out so we can work towards that proficiency level.